Hello then, welcome to this Pandas Challenge, day 18 of 30. My name is Valentine and I'll be your instructor. To get started with this challenge, visit the description section of this video and click on the practice resource link that should take you to a page like what you're seeing on your screen. Once you get there, click on the sample practice resource link and then that should take you to a page that looks like what you're seeing on your screen. Again, it's a notebook. If you're an Afterwork member and you've logged in on our website, then you will get to the practice notebook, which will contain extra challenges that will allow you to practice a bit more when it comes to this particular session. So let's get started. Feel free, by the way, to pause the video and do those particular tasks that we've mentioned until you get to the sample practice notebook or the practice notebook. Once you get there, you need to save a copy in Drive by going to File, then save a copy in Drive to open a new copy of the notebook in a new tab, and then you can be able to make changes to that new copy and save changes on Google Drive. So do that. I won't be doing that in my case. I'll just be opening mine in playground mode, which I have. Then once you do that, then we can now get started. The first thing that we need to do is to import Pandas as PD. So that's what we do here. We import the Pandas library, just run anyway. And that will allow us to now use the Pandas library for our work. And it should take you just a few seconds or so to connect. Once we have connected our notebook to Google servers and have imported the Pandas library, then we can get started with the first concept of this section of this particular challenge. So starting off, we are going to learn how to remove duplicates. This is something that we've learned in the past. So removing duplicates based on specific columns. So assuming that we had this data set and we wanted to just remove any sort of duplicates that might be here based on maybe a phone number or something of that sort. If there are two records that share the same phone number, we will just retain one. So initially, let's first of all just determine the size of the data set. So here we get 75 records by 10 columns. Once we do that, we can then drop the records with that have duplicates, and we use a drop duplicates function for that. To specify or to define our duplicates, duplicates would be records which share the same phone number. So we set the subset column, the subset parameter for the duplicates function to a list of now the elements of the column names that we want to use for defining what duplicates in this case are. We drop those duplicates and then we preview our data, but this may not necessarily give us a useful information, just to know, because we want to know how many records we have at the very end once the duplicates have been deleted, which we do here. We check in this line and we have 20 records which remain. So it means that there are quite a large number of duplicates. But again, you can always perform this technique in different ways. This is just one of the different ways, not different ways, but depending on the research question. In certain cases, you might define duplicates differently, like, if all the columns or all the values of all columns are similar, maybe that's a duplicate, but in our case, we just wanted to focus on this case. All right, pause the video and then work on the challenge. All right, moving on, we might in some cases want to convert columns to lowercase. Maybe if we had this column, the columns that we have in this data set, we might want maybe to convert is it columns to lowercase? Okay, this is a different, by the way, this is a different scenario, but yeah, we could still do that. We might want to maybe to convert which column, maybe all the columns that share that have text values, which in our case would be columns that have the object data type. So first name, last name, email, as well as address, city, state, and membership level. So how we can do that? We can actually use the string lower function and apply it to the specific data frame or even the specific data frame columns. But the issue would be that maybe there could be values which are not do not have the object data type. So in such a situation, we might want to check for, again, to be a bit more thorough, and check for if the data type value, the value that we are going to be converting, any of the ones that are found in these columns, contain the object data type. So for example, we can say for the current value that we want to convert, we want to apply the string lower function if the data type is equals to an object, else we just leave it as it is. Yeah, so that's what we do. We actually use an apply function, but then inside we pass to it a lambda function. Yeah, so I think a lambda function we can practice more later in some other sessions, but for now, you can actually visit the Pandas, Python fundamentals courses that we have on that. We have a series of just Python fundamentals that you can also look towards. So have a look at that. So we have what we have here. All right, run that. Okay, pause the video and then work on the challenge. And you can note, by the way, the conversion that has happened. In certain cases, you might want to replace specific characters in the columns that we have. So for example, we might want to, assuming that we are working with the data set that you would see here, and we wanted to replace maybe the values that, let's say, for example, in this particular column, phone number, we have a dash value. We might want to replace that with a space. So we could first of all define the columns that we want to work with in that situation. Here we are specifying the columns that we want to perform the replacement for. So that's these 4 columns. And then we apply the replace function to those particular columns, specifying inside the replace function the character to replace, which is just a hyphen, and what character we would want to have eventually, which is just a space. And we just set regex to true to perform that particular operation because it's a character that we're replacing. So that would be helpful. And once we have done that operation, we just preview the updated data frame. Right, so that's what we've got. That's what we've got. When you look at the phone number, you'll see that we have replaced the dashes that we had before with just space. All right, pause the video and then work on the challenge. Sampling, sometimes you might want to sample data and sample using random sampling, simple random sampling, where all the elements that would be in a sample had equal chance of being selected. So in our case, assuming we have this data set that contains customer information and we wanted to get a sample, maybe of 5 records, then we can use the sample function and apply to the DF data frame, and we specify inside that sample function the number of records that we want, as well as a random state parameter. We set its value because in such a situation, what we might end up having would be that we would want to have the sample be reproduced, the same sample to be reproduced by other stakeholders that might work on the same work on the same node, on the same data set. So we would want maybe the same sample to be shown to also other people who would run the same code. So that's why we set it as 42, and we then display the output. So we saved the sample inside sample df and display the output. All right. By the way, if you change random state maybe to 2, and you get different records. But if someone else runs your code and has random state at 2, they'll get the same records that you have. Pause the video and then work on the challenge. In some cases, we might want to again work with maybe date or time data. So for instance, if we had this particular data set that contains information about customers, but there's a column that contains maybe date information such as date of birth, we can then decide maybe to do some sort of shifting of of data, and maybe this may not necessarily be a good example, but we could also decide to maybe to add maybe 1 year to what we have here, just to be able to do some sort of analysis that might be helpful. And that operation is just referred to as just adding time delta, where we just want to perform a data arithmetic operation, such as either adding or subtracting a specific duration. So in our case, again, just like before, we would first of all convert the data that we have here, the date type. Clicked on the date type. We would need to convert the date of birth data into to have a date what's it called date data type. So that's what we do here, to have a date time format. Then afterwards we now define our time delta object, which will be now the number of days that we want to add to the date of birth, which is 30. Then we create a new column that will contain date of birth values, plus now the time delta object, which essentially just increases the date of birth values with 30 days, and the output is stored in new date. And yeah, here we just display the output. You can see new date, which when you look at closely, we have this is July 15th, and we have 30 days. This is August 14th. Okay, all right, pause the video and then work on the challenge. All right, in some cases we might want to subtract. So here we added time delta. So in some cases we might want to subtract a time delta. And it could be still the same case that we had, assuming that again we had the customer information with date of birth on the far right, and we wanted to subtract 30 days. This is May 10th, maybe April, you'd expect April. So we just use a negative, not a hyphen, to subtract now the date of birth, and to subtract the delta from date of birth. And we specified it to be days, and we can specify it to be months or even years. Right, when you look at the new date of birth, you see that we have April 10th. Right, pause the video and then work on the challenge. In some cases, we might also want to still, continue working with date data, but we might also want to shift maybe the dates by 1 year. So here, it's almost close to what we have done in, the previous case where we worked with time delta objects, but we could also want to offset, maybe shift a date by 1 year. So from here, we might want to work with 2021, the join date, not just 2020. So we first of all perform the date time conversion for the column that we want to work with. That's the date column. Then we define the date offset object that we have here. Then we apply that offset object to the year. That's the join date, and then we create a new column, and then we just display now the final outcome. So where we have the shifted, we have date, that shifted date here, year from that particular time. Right, pause the video and then work on the challenge. Sometimes you might want to delete columns using the pop method, which we did in the previous challenge, that's 17. And it's not that hard. It's just we use the pop function, and then we specify inside that pop function or the pop method the date that we want to delete, the column that we want to delete. Like in our case, we want to delete phone number, and that just essentially deletes that column from the data. And you can see this is a new data frame that doesn't have that column. Right, pause the video and then work on the challenge. In some cases, we might want to use or have summary tables that are based off bigger tables. Say, for instance, if we had this data set that contains information, again, still about customers, which you can see here, and we wanted to have a smaller data table, summary data set that would contain maybe gender as well as the values for state. So gender, and for each and every state, we might want to have maybe the occurrences of the values per gender. So for each gender, we want to check for, let's say it's male, female, we would want to check for the value for New York, how many are in male, individuals or female individuals are there for New York. We would use the crossed-up function for such an operation, and where we specify in that summary table on the left-hand side the gender column, plus on the right-hand side the other column, which should be categorical in nature, which would actually have to just give us the state values. So we'd have multiple columns based on the categorical values in this column, and would plot that and be able to get the values for that. So you can see here we have state, well, let me put a reset index function to have a data frame output. So here it doesn't clearly come out that we would want state. We may not necessarily want to have this, but we can always reindex that column. But again, we have gender, female, male, then we have the states and the respective values for each and every state for the gender column, for gender values. Okay, pause the video and then work on the challenge. Moving on, we can decide to perform filtering in order to focus our analysis on some sort of research question, so that we have just relevant records for just the research question that we are working with. So for example, we might have this data set that contains, again, information about customers, and we may decide maybe to just only work with records that have age or value of greater than or equal to 30, and also maybe of states California and Texas. So again, in the past we also got to learn how to do this. We would need to define the conditions that we want. Here we are using we have a Boolean mask as well as another one here, but we're using the is in function for this at the second case. And then we're using a log method. So we are using that is shown here, and we display the output. So generally we're just performing filtering, but passing our conditions to the log method. All right, pause the video and then work on the challenge. Okay, so that's it with regards to this learning experience for this particular day. We hope that you found the resource that we have provided useful, and if you'd want to be informed when we post such future challenges, be sure to subscribe, and actually don't forget also to give us a thumbs up to just tell us that we're doing a good job, and also tell people that this is a useful resource. All the best in your learning journey. Bye bye.